In this video, we shall talk about some basic concepts on vectors, things like magnitude of a vector, direction of a vector, components of a vector, and concepts on basis vectors utilizing unit vectors. A vector is a quantity with both magnitude and direction. Now, we can represent a vector graphically in the following manner. With an arrow like that, and we can symbolize this arrow with a letter with arrow over it. So this represents vector A, or vector B, vector C, and so on. Next, we shall look at magnitude of a vector. So what is a magnitude of a vector? Now, if we have a vector, let's call this vector vector x. The magnitude of this vector x is given by this length of this arrow. So that is the magnitude of this vector x. Now we shall use the following symbol to denote the magnitude of vector x. That is how you represent the magnitude of a vector. In this case, vector x. Now if you have another vector, let's say vector z or z, then the magnitude is given by that length and that is how we write the magnitude of this particular vector, and so on. What about the direction of a vector? Direction of a vector is represented using angles. So before that, let's introduce the four quadrants on an xy plane. So this is the x-axis and this is the y-axis. So the top right region is called quadrant 1. On the left, it's called the quadrant 2. Bottom left, quadrant 3. And then you have quadrant 4. So if you have a vector, let's say in quadrant 1, vector goes like that. The direction of this vector, let's call this vector B, is given by an angle measured like that, theta. If you have another vector, let's say in quadrant number 3, let's say like that, the direction of this particular vector, let's call this vector vector C, is given by an angle defined like that. Let's call that theta. And as you can see, theta is measured beginning from the positive x-axis, going counterclockwise all the way until you hit the vector in question. Again, if you have a third vector in quadrant 4, let's call this vector vector F. So the direction of this vector F, which lies in quadrant 4, is given by an angle defined like that, and so on. Components of a vector. Now, what are the components of a vector? If you have a vector like that, let's call this vector vector E. The magnitude of vector E is 5 units. So that means the length of that arrow is 5 units. Now let's assume that this vector makes an angle of 30 degrees with respect to the horizontal. So what are the components of this vector E? Now there are two components to this vector E. The first component is the x component, and the second component is the y component, right? Now let's look at the x component. The x component is the length of this distance here. So we shall denote the x component with the subscript x, and the y component is the length of that distance. and we are denoting with a subscript y. Okay. Now how do we calculate EX and EY? Now we know that we have a right angle triangle, so we can rely on trigonometry to calculate EX and EY. So first let's look at EX. Now EX, using trigonometry, over 5, which is the hypotenuse of this triangle, equals cosine of 30 degrees. So that means your EX is 5 times cosine 30 degrees, which is about 4.33 units. Now likewise, to calculate EY, EY over the hypotenuse 5 is sine of 30. So that means EY is 5 sine 30. That means you have 2.5 for the y component and 4.33 for the x component. Another example. You have vector g with magnitude 7 making an angle of 20 degrees with respect to the horizontal. So this is the x component of this vector g, and that is the y component of this vector g. Now this is again a right angle triangle, so you can use trigonometry to figure out these two components. Now first, the x component. So gx over 7 is cosine 20 degrees. So that means gx is 7 times cosine 20 degrees, which is 6.58. Likewise, gy over 7 is sine 20, and gy equals 7 sine 20, which is 2.39. So you have the y component and the x component of vector g. So you see that if you are given the magnitude of a vector and the angle that vector makes, for example, the x-axis, you can figure out the two components. Later we will see if you're given components of a vector, you can figure out the magnitude and the direction of a particular vector. Next, let's look at the concept of basis vector. Basis vectors are building blocks that we can use to express other generic vectors. And we build basis vectors using unit vectors. The three unit vectors that we can use are as follows. I hat, a unit vector along the x-axis, j hat, the unit vector along the y-axis, and k hat, unit vector along the z or the z-axis. Now, they are called unit vectors because their magnitudes are all 1. This is how we write a generic vector in terms of unit vectors. Vector b with an x component of -2, y component of 1, and the z or the z component of -3, for example, right? Or vector g, which is minus j hat plus 5k hat. So just examples. If you have a vector f given as shown and you want to calculate the magnitude of this vector f, how do you do it? Now you have the x component -2 and the y component 8. So to calculate the magnitude of vector f, you need to square the components and then sum them up and square root the sum. So in this particular example, the magnitude is square root 68, which is about 8.24 units. Another example, vector c, the magnitude of vector c. the same. You take the square of the x component plus the square of the y component plus the square of the z or the z component, and then square root them, and you get square root of 35, which is about 5.92. Let's look at how to calculate the direction of a vector. So if you have a vector d as shown, minus I hat plus 4j hat. Now first you trace or you plot the components on xy axis, because this is a two-dimensional vector. So the x component is -1, so that's -1. The y component is 4, positive 4, like that. So that means vector d goes like that. So the direction for vector d is given by that angle theta. Now before we calculate that theta, we have to figure out this alpha, the acute angle alpha. That can be done from trigonometry. Let's trace this right angle triangle. So this is a right angle triangle. Magnitude of this side is 1 and that is 4. I'm ignoring minus from this -1 because what I'm interested in is the acute angle alpha. So you can immediately see that tangent alpha is 4. So alpha is about 76 degrees. Now what does that mean? That means theta is 180 degrees minus 76 degrees, which is 104 degrees. So this 104 degrees is the direction for this vector d, and as it should, because it lies in quadrant 2. Another example, a vector h as shown. Now let's plot the components on the xy axis. So as you can see, it has an x component of 2, y component of -7. So that is 2, and -7 is there. So vector h looks like that. So the angle that you are interested in, the angle that would specify the direction of vector h, is the theta right there. But first we calculate the acute angle alpha. Again, we use trigonometry. So this is alpha, this is right angle triangle, this is 2, and this is 7. I'm ignoring again the minus sign from 7 because I'm interested in calculating the acute angle alpha. So we see tangent alpha is 7/2. So alpha is about 74 degrees. Now what does that mean? That means theta is 360 minus 74, which is 286 degrees. So this is the direction of vector h. So as you can see, if you are given magnitude and direction, you can calculate components, and likewise if you are given components, you can calculate direction and magnitude of a vector. I hope you found the video useful. Next time we shall look at how to add and subtract vectors, multiply a vector by a scalar, and taking dot product of two vectors. Until then, thanks for watching.